before I get into the kind of the main topic of the talk, I thought I'd touch on a couple of telecommunication events in history that happened here in Kansas City. The first is that there was, in the late 1800s here in town, there was an undertaker. His name was Almon Strowger. And he noticed that business was kind of declining, and as the story goes, he discovered that it was because one of the local switchboard operators, the manual telephone operators, was sending business elsewhere. I don't know, I can't remember the details. It might have been to like her husband or her boyfriend who was a competing undertaker. Anyway, he invented public switch telephone networking in anger, and I kind of get a kick out of that stuff. No, he invented, what we call pulse dialing today, or the old school rotary switching back then, and he invented the Strowger switch, and that was what people used to connect, telephone calls up until, the late 1800s, and I think the last Strowger switch went out of service in the early 2000s. So he had, something that he invented that lasted more than a century in production. The other thing that happened here was something called the Southern Pacific Railroad Internal Networking Telephony, which was kind of a clumsy name, so they kind of shortened that to Sprint Corporation. And that, let me back up one. Sprint Corp, and the reason I bring this up is because when they spun their telephone operation, what they had done was lay communication lines along the railroad tracks and started sending calls back and forth, and thought that, hey, we can sell long distance telephone service using this. And when they did that, when they formed Sprint Corporation, which became one of the larger employers here, they got sued by AT&T. And AT&T lost, big time. AT&T losing these lawsuits was a really big step in the migration from having a single, long-distance monopoly to having more open competition in the U.S. And I think this happened in the 80s, but I think that really set the stage for the explosive growth of the internet, in the U.S., at least here in the U.S., during the 90s. And the thing that Sprint, well, it's part of T-Mobile now, but the thing that they run that's really near and dear to my heart is that they have a web server, www.sprint.net, that is on the IPv6 address 2600, period, just that address, 2600::. So whenever I need to test IPv6 connectivity, this is what I ping. And if there's anybody here from T-Mobile, keep up the good work, man. This is awesome. We are here to talk about, at least I'm here to talk about Wireshark. I don't know about y'all, but we have a major release coming up, hopefully at the end of the summer. And as Roland pointed out, with climate change kicking in the way it is, the end of summer could be maybe December or January, so we'll see. But we have a lot of new and exciting changes coming up that are really cool, I think, at least. And so we've bumped the major release version number to 4.0. And if you're wondering why that is, that's why that is. One of the big changes that are coming up are changes that one of our developers, Joao Valverde, made to the display filter engine. Joao's not here. He's enjoying his beautiful home in Portugal instead of being here, so what are you going to do? So I'll talk about it. But before I get into the display filter changes, it might be beneficial to kind of do a quick refresher over how filtering works and where filtering works in Wireshark. If you don't quite understand this yet, that's why we're here. That's why we have this conference. We're here to teach you this sort of thing. So there will not be a quiz, so just sit back and relax. Anyway, the first thing we should probably point out is that Wireshark, the main application, does not capture packets. That job is done by a suite of utilities down here. Like, dump cap is the main thing. That's what captures packets on the network. But we also have SSH dump and other utilities like that. But Wireshark just reads capture files and lets you analyze them. The actual job of capturing is done down here. And that's kind of a good way to break up the actual application into the main component the main component processes that are running. But if you look at this, you realize, okay, I'm bringing in packets down here and I'm analyzing up here. And at each of these places, it's useful to be able to filter those packets, either as you're bringing them in or as you're interactively analyzing them. And that's why we have two separate filtering engines, and we have two separate filtering languages. As I said, the main updates are the display filter language, but I'll touch on the capture filters here as well, just for completeness. Capture filters operate on the packets as they come in. The bad news is we only let you apply them once at capture time. And the other bit of bad news is capture filters only really let you ask questions about what numbers are in that packet at a certain position in the packet. The good news is you can get really far asking those types of questions. You can build up these really complex, rich capture filters. And as it turns out, computers are kind of good at handling numbers, and so they're really efficient at this. As an example, yeah, here we go. Suppose we want to filter on this, IP source 172.16.0.122. Well, that gets compiled down. I want to use both of my hands here, sorry. That gets compiled down to this little teeny bit of code with just a few instructions. And the first thing it checks is, assuming we're on Ethernet, it'll scan 12 bytes into the packet and look here in this position. And it'll look for 0800. Well, I guess my slides are kind of off. Sorry about that. It'll look right here. And that's a check to see if we're running IPv4. And if we are, it'll scan a little bit further and look for our address, which is, I think, 26 bytes in. But anyway, it's around here somewhere. Sorry, the alignment's off, but I guess we'll have to fix that in a bit. And that's all it does. If it matches both of those, then you win, you capture that packet, and you move on. Display filters, on the other hand, excuse me, they get applied to what you see here in the Wireshark main window. They get applied after Wireshark is done looking at that packet and going through a process called dissection, where we take that packet and break it down into as many of its component fields as we can and provide as much detail about those fields as we can. And so, the good news here is that instead of just being able to ask questions about what number is where in a packet, you can ask all sorts of really cool questions like, what text is in the packet, or is this checksum valid, or did this packet arrive within 450 milliseconds of the previous packet, or what does the packet look like after you've decompressed it or decrypted it, and things like that. That's the good news. The bad news is, as you might have guessed, this takes quite a bit of CPU processing power, and so if you have, say, 50 million packets, you're going to be sitting there a while if you apply a display filter. But for most jobs, it's fast enough and it's useful enough. Now, to compare what we had before, with the capture filter, if we compare that to a display filter, we applied the same filter, IP source equals 172.16.0.122. What happens is Wireshark dissects that packet, breaks it down into the different fields, and then it scans down and it looks for a field named IP source. And then it looks at the address and compares them. So we're, as you can see, we're not really looking at the raw packet bytes anymore. We're looking at information that Wireshark has extracted from that packet. So, as I said, there are a whole bunch of changes made to the display filters. I'm not going to read down the list, but the first one I'll talk about is the changes to the field matching. If you want to see the complete list of changes that were made, you can look in the release notes for the latest development release, which is 3.7.1. You can also look at the documentation. Once we publish that release, we're going to update the documentation as well. So to talk about the field matching changes, we should probably maybe start off with this question. Excuse me. How many times does the field IP.source show up in a packet? And the sort of naive answer to that question is, well, if it's not an IP packet, it's going to be 0. If it is an IP packet, it's going to be 1. But the actual answer to that question, I see Jasper shaking his head, but the actual real answer to the question is, you can get as many of these into the packet as your imagination and the laws of physics will allow. This is an example from something called the Ultimate PCAP. It was made by Johannes Weber. I don't think he's here today. He might be attending remotely. I don't know. But It's this huge capture file with all sorts of different protocols in it. But in this particular case, we have IPv4, as our outermost layer. It's carrying something called GRE, Generic Routing Encapsulation, which is a tunneling protocol. And there are all sorts of different tunneling protocols out there. And it has another IP4 header. And that's carrying an ICMP message, which has an error message, which has another IP4 header. So we have 3 IP sources in here and 3 IP destinations and so on. To sort of compound the issue, we also guarantee that you're going to double up on some fields because we have these fields like IP.adder, which is more of a general term. It matches either the source or destination address. We call those aliases. And TCP.port, which matches either the source or destination port. And we put it in there as a convenience to you, but at the same time, this guarantees that we have multiple occurrences of these fields in a packet, which, as we'll see in a second, kind of makes things a little bit vague. Let me take a dramatic pause here and get a drink, sorry. As an example, if we say IP.adder equals 10.10.10.1, it will match either the source or destination address, and as it says over here, if any of these match, we have a winner. So in the previous example, if any of those 6 address fields match 10.10.10.1, we're good to go, and we match that filter. If we want to, wow, man, sorry about the layout. I had to switch from Google Slides to macOS Keynote, and boy, the layout changed. Sorry, but we'll get through it. Anyway, if we want to negate that filter, we can say not IP address equals 10.10.1, and that will switch things around. And if any of those packets, or if any of those addresses does match 10.10.1, we will exclude that packet, and it will not show up in the display filter or in your packet list. And you kind of do that in order to exclude traffic that you don't want to see, that maybe is not interesting or is kind of noisy or whatever. In Wireshark versions up until 3.4, we kind of did something confusing. We did something logically consistent, but maybe not what was useful in analysis. If you said IP.address is not equal to 10.10.1 in earlier versions of Wireshark, as you can kind of follow along, it said, if any of these fields doesn't match, then we have a winner, which was useful if you only had one field occurrence, like just one IP source. But if you had multiple fields, then it did exactly the opposite of what you wanted to do, at least for IP addresses, because if you think about it, in each IP packet, you have a source and destination address, and typically those are different addresses. And so you're going to have maybe one address that's 10.10.10.1, but the other address will be different. And so since it matches this, or it matches that wording, then it's going to show up. It'll do the exact opposite of what you wanted to do. And we got complaints about this over the years, and so we finally fixed it so that in 3.6 and later, it does kind of what you want it to do. It matches this behavior up here, and it's more consistent, according to what we document and what we tell you to do. Sorry, I'm kind of having to compress a whole bunch of Boolean logic into Morgan's theorem and stuff like that into one slide, and this could be a whole, sort of half-hour session, but if you want to talk about it after the talk, then we can, but that's just to let you know we fixed something that people found confusing. The changes that Zhao made to the display filter engine that kind of follow along with this was, for completeness, he added an all operator. So along with not, we have an all operator that says, in this case, all IP sources in that packet have to match 10.10.10.1. I don't know if this makes sense for IP, but it might make sense for other protocols, and there are plenty of other protocols that we support. I'm just using this as an example. Along with this is an equivalent thing. We have a triple equals operator, which I always interpret as this is really equal to, but but it's these have the same behavior. Again, I think this will be useful for some corner cases, but maybe not for general analysis, but still it's there for completeness, and I'm glad he added it. The big thing that I think everybody's going to be really excited about and find useful is something called the layer operator. And now you can say IP source number 2 equals 10.10.10.1, and if we go back to that tunneling example, we can now match a specific occurrence of IP, a field in a packet. So IP source number 1 matches that, IP source number 2 matches this, and so on. IP source number 3 is down there. Again, I apologize for the layout of the slides. We literally switched presentation software 3 minutes before this talk, so I'll try to fix it up later. A really cool thing that Gerald did was add arithmetic. You can do math on fields and packets now, numeric fields. So if you wanted to add 2 ports together, or add a length in a port, if you want to do crazy stuff like that, you could do that. Just all the arithmetic you learned in elementary school. The one thing that kind of stuck out to me was that we now support something called the modulo operator, which that's something we use in software development all the time. The modulo operator gives you the integer remainder of division, meaning that, say, 5 modulo 2 gives you 1, because 2 goes into 5 twice, and then you have 1 left over, and that's the, the modulo result. And so, as kind of a contrived example, suppose you have an internal protocol at your company that always sends, 1 or more 512-byte blocks, and they all, it has to be a multiple of 512 bytes. And suppose something out there is acting flaky and it's sending out the wrong length blocks. Well, you could find that by using the modulo operator. You could say tcp.length modulo 512 is not equal to 0. So anytime you have a remainder of a multiple of these, that's where you find your in-string and troublesome traffic. And on top of that, if we say the length is greater than 0, you can always find packets that are shipping data, but they're shipping the wrong data. So like I said, I think people are going to find this useful, although it'll be kind of this really weird corner case that you're going to have to track down, but it'll show up, I think, in answers in the future. As I recall, arithmetic needs to be in curly braces. Don't quote me on that. I do know that the syntax was updated, and it continues to be updated, so that might change. I must say this is a highlight of my career because I found a valid technical reason to use the pile of poo emoji in a presentation. But no, this raises a valid, serious question. If you're not familiar with this filter, we're using something called the contains operator. And the contains operator says, okay, Wireshark needs to look for everything between these 2 quote marks. And okay, you managed to type in a pile of poo emoji and put it in those quote marks. What does Wireshark actually look for in the packet? What bytes does it look for? Because it's not apparent. If you've ever had to mess around with character encodings on computers, and if you see something that kind of gets mistranslated, I think it's called mojobaki, where you have something that goes in on one side and it comes out as gibberish on the other, you've had to deal with this. So you might think, okay, this has something to do with Unicode, and you'll be right, because the pile of poo is not present in ASCII, it's not present in EPSIDIC or Windows Code page 1252 or ISO 8859-whatever. But it is present in Unicode, in the Unicode specification. And so that answer is right. TCP.payload contains pile of poo. It means Wireshark looks for these bytes, F09F92A9. And that's because in version 6.0 and later of the Unicode specification, in the miscellaneous symbols code block, they have a picture of this, the pile of poo. And that's the, the official glyph. The official number that they've assigned to it is U1F4A9. The official name, it's written in the spec, I've read it, is pile of poo. And the on-the-wire representation in 8 bits, because there are also 16 and 32-bit representations. But the 8-bit representation is F09F92A9. So that's what Wireshark looks for. And there it is in the spec right there. That's the URL. And along with that, there are other ways to look for text in Wireshark. For a long time now, you've just been able to type in text. And I mentioned UTF-8 because that's really what we try to use within Wireshark. And it's 2022, and that's what the world uses. And so if you're not sure what sort of encoding format Wireshark uses in any particular place, we try to output UTF-8 in T-Shark. We try to convert whatever you type to UTF-8 in the display filter rules. We try to, it's just what we try to read and write and represent within the application. So you can always, it's a safe assumption that we're going to be using UTF-8 wherever that might not be apparent. But anyway, if you want to look for the pilot-poo, you can do this. You can type that. I have a little, macOS comes with a little utility that lets you type this really easily. If you're not running macOS or if you don't have that available, you can do this. Remember, this is F09F92A9. What we're doing here is using something called hexadecimal escapes, meaning \x and then the hex value \x and the hex value and so on. You can do that within quotes, just to get the raw hex numbers. If you don't want to mess with this, you can also type in the raw hex numbers just by typing them directly and putting quotes between them. And finally, in 4.0, you can use the Unicode code point number by using \u. Remember in the previous slide, that's the official number in the specification, and now you can type that in there and look for that value. So there are all sorts of ways to look for text in the wire or in a packet in Wireshark, and this is just kind of a few of them. So I talked about the \/ escapes in the previous slide, and we do support all these different ways of encoding special characters using backslashes, and that can be kind of troublesome because if you ever worked with Windows, I do sometimes, you notice that things like file system paths have backslashes in them, and so if you wanted to look for TCP contains and C:\foo, normally you have to double it up. You have to escape out that backslash. With 4.0, or maybe it was 3.6, I can't remember. Anyway, with recent versions of Wireshark, you can use what's called a raw string. You can put an R in front of that quoted string, and that tells Wireshark to just take all those backslashes and make them literal backslashes, so you don't have to mess around with worrying about whatever's going to be converted within that string. If that looks familiar, it's because we kind of adopted this from Python. That's the syntax that they use and the convention that they use. Finally, before Roland comes up on stage, I wanted to cover this. For a long time in Wireshark, we've supported what's called a slice operator. Earlier I talked about looking for what bytes are at a place in a packet. And Wireshark kind of does it this way. We use, again, this is kind of adopted from Python, but we use what's called a slice operator. You can say, okay, starting at position 0, the very beginning of the packet, and those 2 bytes starting at the packet, look for these hex values, BBCC. And that's how you find bytes that are in a specific place in a packet. We could, if we wanted to look 10 bytes or 12 bytes into the packet, we'd use 10 or 12 here, and we can change the length here by using 2 or 4 or 5 or whatever. The problem is, that assumes that you know where the bytes are in the packet from the start. If you, as the question says, if you want to match the last 2 bytes, what are you going to do? Because the length might be variable. You might not know how long the packet is. And another dramatic pause. Hold on. Use a negative start index. What we're doing down here is we're saying, okay, instead of starting at 0 at the very beginning of the packet, go to the very end of the packet, and then back up 2. And, oops, before I trip. And that's how you match the very end of the packet. So you could say -2 or -4, just to back up to the last 4 bytes of the packet and so on. This is, again, adopted from Python, but I think somebody's going to find this useful because this is just, I think it's really cool personally. All right, I'm done talking about filters. Please welcome Roland Knall up on the stage. He did a lot of work on our conversation code.
So, a developer's point of view is always we break stuff because that just makes it more fun. And one of the things we did with Wireshark 4.0, or one of the things we strive to do with Wireshark 4.0 is to get some changes in that otherwise wouldn't be possible because it breaks too much of the UI or it breaks too much of certain behaviors. And one of those things we changed is the conversations dialogue. So the conversation and endpoint dialogue, it will come up for those of you who are new to the program in various training scenarios, and the old guys use it pretty much for, I think, on a daily basis. It's one of the get-go statistics dialogue when you start out analyzing an issue. It's one of the first things you take a look at. So a little refresher for those who don't use them that regularly. Conversations and endpoints from a Wireshark point of view. We're not talking about conversations like in TCP conversations. So conversations is who is talking to whom, and endpoints is who is talking at all. This is what the conversation dialogue used to be looking like. Basically just giving you the plain information. The thing is, with a lot of stuff inside Wireshark, this is something that has been written by engineers to be used by engineers. Now, when you're new to Wireshark and you start out with that dialogue, you have no clue what to do. And so one of the ideas was to get this dialogue into a visual state where it's easier to look at, easier to understand, and maybe getting you faster to comprehend. And this is what the new one looks like. It's the same information, it's the same content. You can do a lot of stuff more than you could do until now, but it's looking a little bit cleaner. It has more on the point what you can configure, stuff like that. And the main things that have been going on are on the inside. So for instance, what you can do, one of the things that had been requested quite a bunch of times is the data can be exported as CSV and YAML already, but now we can also do JSON. When you do JSON, you export it including the field names. So you can easily have a whole conversation table, filter that, and export it as JSON directly into your Python program. The second thing is, and it's shown here on the right-hand side, you can detach now. So when you go here, this is the IPv4 pane, and you can detach those pane, you can slide them above each other, you can compare it. TCP, UDP, for instance, have it side by side, compare what is talking to what. Makes it easier. Of course, when you close that pane, it reattaches, it's saved so that you know, okay, this has been opened, and stuff like that. One other things, you can hide columns now. So when you right-click on the columns, you don't necessarily need all the information. You can just present the information that you need. This is profile saved, so you can create a profile for your students. You can profiles for your colleagues where you just, for instance, have the IP addresses talking to each other with the number of packets, number of bytes, because this is all the information you ever need. And there is one more thing in there. One that's actually been directly taken from one of Chris Creer's YouTube videos. One of the things the conversation dialogue can be used for pretty easy is figuring out if there is a port scan going on in your network. Because all you have to do is you fire up the dialogue, you just let it scan for a few minutes, and then you have a lot of conversations that have just 1, 2, 3, 4, 5 packets. You can now filter for those. So what you do is right-click, exactly like in Excel and other table calculation programs, you right-click on the column and say, okay, please show me all entries that have less than 3 in it, or less than 20 in it, and stuff like that. Yeah, that's basically it. We have a lot more stuff going on.
Sure.
Wireshark, should I? Or you
do you want to?
Yeah,
go ahead
sure.
if you want to, sure.
So one of the things that's actually going to be a little bit of pain in the ass is we stopped supporting 32-bit. So Windows is only 64-bit from now on. 3.6 will be supported until, I think we have 4 years or 5 years?
2024. So if you're using 32-bit Windows, you can still use an older release of Wireshark. You just won't be able to use 4.0 or later, unless you build it yourself.
Yeah. Well, we're working on the last entry. We're working on Windows on ARM, which actually is not that easy to do right now because Microsoft is just porting really important stuff to the ARM platform. For instance, the first Visual Studio platform, including all the compilers that has native ARM support in it, will be released by the end of this year. So the only build we have available is a pre-build.
One of the holdups there on supporting Windows on ARM is also getting a piece of hardware that is stable and secure enough to put in production to build those packages. And once we do that, then we can maybe support that platform.
Development for that is happening currently on Apple Silicon hardware, because that's actually the only really stable, productive hardware you can use to develop Windows on ARM.
Right.
If somebody from Microsoft is listening, take note.
Just before we get into the next slide, right after this is the time in the talk where we bring up the core developers, so if you guys want to get ready. And if you have any questions for the core developers, now's the time to think of them. And if you're attending remotely, now's the time to maybe type them into Discord for the moderators to read out. But anyway, on with the show.
Okay, I make the bottom two one, you make the top one, right?
Okay. All right.
Start out with the top.
Sure. Well, the very top line, the import from hexdump and text to PCAP improvements. If you've ever worked with gear, there's a lot of gear out there that will dump out packet data as a hex dump because they're kind of being, I don't know, maliciously conformant to whatever spec they're following. You know, they're not just giving you a PCAP of the packets. They're saying, here's the packet data, you get to deal with it, as a hex dump. And how we deal with that in Wireshark is in the main UI, in the main GUI interface, we have a feature called import from hexdump, and on the command line we have text to PCAP. Up until very recently, those have used different code bases and had different behaviors and feature sets, and one of our developers did a really great job of unifying that, and so now they have the same code and the same feature sets and the same behavior, and so hopefully if you have to deal with that situation, life is now easier for you.
The second one is a user improvement for new users, especially when you're sitting on hardware like the MacBooks, for instance, and you fire up Wireshark for the first time, you maybe have Docker installed as well and stuff like that. You're going to get a bunch of interfaces, you have no clue what they're doing, and you're searching for the one interface that you want to capture on, which makes it pretty hard because where do you find it? Usually what you do and what most of the tutorials tell you is go down the list, find the one that has some spikes in the line, and that's the one you're using. So for Wireshark 4.0, we changed that. The interfaces that actually have packets coming in will always be on top of the list. It takes 1, 2, 3, 4 seconds to adapt to because we are actually looking at the interfaces, and so the list can change at the beginning a little bit. But after a while, you will always see those interfaces on top, and those are the interfaces you can focus on. And on a normal PC, it's usually just 1 or 2. Usually it's a network interface and the loopback device, that's it. The third entry here is Qt 6. So Wireshark 4.0 on Windows and Mac OS will be released using Qt 6.
Qt is?
Pardon?
Qt is the user interface library that we use, and that's what gives you the same look and feel on Windows and Mac OS on Linux.
Yeah. We're not yet sure which version we're going to use. 6.3.1 is the current one at the moment, but it still has some bugs, so it depends on which version they're going to end up at the point we release. Is this important for 99% of the users? No. This is most important for people doing their own development stuff. Linux-based Wireshark versions for now are Qt 5-based at the moment, but we're talking about making Qt 6 mandatory in dev, so pretty much they're going to move to Qt 6 as well. And one of the things to look out for, there is a discussion about the license modeling of Qt going on online. You, as a user, don't have to care about that. So if you ever have a discussion going inside your company, the program uses Qt 6, are we allowed to use that? Yes, you are. That's something we have to think about and we have to take care of, and our get-go response is, well, we're open source, we don't make money from it, so that's usually how it goes, but yeah.
I think. All right, this is the time in the show where we bring the core developers up on stage, and this is, if you guys want to come on.
You want to ask us any questions or respond to anything? Do we have questions? No?
Why don't we pass the mic down and let people introduce themselves?
Well,
No, here,
I could go as well as first.
Sure.
And then go on. So I'm, by the way, Roland Knall, as said before, Austrian guy. Been with Wireshark, I think 2016 it is now. And usually I'm doing all of that work in my spare time because I'm not getting paid for Wireshark at all or in any kind of capacity of doing network analysis. My current day job is building model trains, literally. And well, my take to the program was initially I want to fix stuff that annoyed me at my old job, and that's what I did. And this is my get-go response if somebody asks me, how can I get feature X in Wireshark? Well, we fix stuff that annoys us. If you annoy us a lot, we fix stuff that annoys you. Annoying us usually helps with all kinds of beverages, alcoholic ones preferred, and chocolate. We are greatly annoyed by chocolate.
John Thacker. I've been using Wireshark for 10 or 15 years, but only recently in the last year or two became a core developer after submitting other changes for a while, but started having more time to work on it.
Yeah, Uli Helmer, my name. Wireshark user also since more than 18 years or so. A long time ago. First contribution was, I guess, 2013, and also like Roland, I missed dissectors, and so I started to develop it. Yeah.
I'm Alexis from France, and I am co-developer for 10 years.
My name is Jaap. I'm from the Netherlands. I'm working as a core developer since 2004. Basically came about as in, like before, there were some features missing from what we could see, so I started sending in patches, and eventually I annoyed Gerald enough that he said, okay, do it yourself.
I'm Saike Blok from the Netherlands. I started using Ethereal in I think 1999. So, and then, I was missing features, missing some dissections, and wanted to ask for it. And then I saw, I can do it myself maybe. So I did that and supplied it to the mailing list. That was our main way of supplying patches back then. And since I was using it on Windows and I developed on Linux, I wanted to have the automated build quickly. So I annoyed the hell out of these people to submit my patches so I could use it on Windows. And so after a few patches, they allowed me in the team. And I've been doing quite a bit of development between 2007 and 2012, I think. And since the move to Qt, it's not my cup of tea yet. So I need to get back in the game. So. My day job is analyzing, so I'm not a programmer. I'm a networking guy doing intelligent copy and pasting to programs. So.
Hello, I'm Chris Maynard. I work for IGT. I became involved with Wireshark or Ethereal maybe 15, 20 years ago. We were developing a new protocol and wrote a dissector to dissect it. And now I maintain 50, 75 dissectors written in C and Lua for my company. Similar to other developers, other features either annoyed me or I was able to peruse the bug list and fix some problems that other people had and submit those patches. And then I kept contributing from there. These days I mostly moderate the Ask Wireshark org site. So if you have questions about Wireshark, that's the place to go primarily. Or the Wireshark Dev mailing list. Submit questions there, but I think the Ask site is probably the place to go.
Anders Broman from Sweden. I work for Ericsson. I started with Wireshark 2003, I think it was, mainly as a hobby. And of course I needed some of the stuff for work, so I did it to be able to analyze protocols. And eventually I was asked to maintain our internal version of Wireshark, so I have around 85 protocols I maintain internally. And I've also done many of the ASN1-based dissectors in Wireshark. It's used heavily in telecom. Yeah, that's it.
So, does anyone have any questions? I mean, this is a, yes?
Let me just repeat the question for the online participants. So the question was IP slicing, if we would be able to address if a certain IP address is part of another encapsulation protocol and address that, specify that address as well, right? Did we get that?
We don't know a priori which IP address is in the package.
Okay.
I don't think directly, but if you had a mix of, say, just plain IP and then IP and GRE packets, suppose you had that, you're going to have a filter that you can use the filter GRE to match just the GRE packets, right? And then you can use IP number, IP layer number 2 to match the stuff inside that GRE. I mean, you can do stuff like that. I hate using this answer, but because it's always the fallback, and it's always the fallback everybody hates. But you can also use a Lua script, and kind of customize it that way, and maybe pull fields out that way. But yeah, I don't know that we let you chain, specifically chain stuff like that. That's probably another enhancement that we're going to have to make.
Yeah, I've got in addition to that, there is a field called frame.protocols. It has the whole stack of protocols. So you can at least match the protocol stack that you want, and then you know which precision is which IP address. And then if you have multiple occurrences of different protocol stacking, you can combine that into a large filter. So that would be the current clumsy way to do it.
Okay. All right. It looks like we have a question from a remote user.
Yep. The question is, do you have a guide on how to set up a dev environment for contributing to the repo?
The question is, do you have a guide on setting up a development environment for contributing to the repository? And Roland lunged for the mic, so.
We do have an online developer guide which contains information about doing that. I would just add 2 points to that guide. First of all, it's a clean setup environment which we are having in the guide. So if you have a different setup on your system, then it might vary a little bit. And you have to navigate that. And the second thing is, I would just emphasize setting up a development at this point for Qt 6, because this is going to be the default option going down. And the guide, I think, still specifies Qt 5, but that's going to change. And the third thing is, if you can avoid it, avoid Windows. And that has nothing to do with me being biased towards the Microsoft operating system. It has a lot to do with how Visual Studio works and how development on Windows works. And it's just for newcomers easier to develop on a platform like Linux or Mac OS than it is for Windows.
Well, one of the points I made years ago on one of these talks was, developing open source on Linux is basically 3 commands. You set up your build environment and then do a make and make install. On Windows, it's a lot more like an IKEA motorcycle engine. So, just.
And just for the previous question, unfortunately, since Joe isn't here and he would be the best person to answer all the filter questions.
Yeah.
But from what I recall from the changes that he made, there's a layer number that was added that is the layer number of that dissector within the frame, not the overall layer number, which means if you're worried about some of the cases where you have IP and GRE and IP, but then some of your packets have VLAN and some of the packets don't have VLAN, or some of your packets have something like that. So you'd be worried that the IP layer, you don't know what layer that is in the packet, but if you did know that that was the second layer of IP, that would be what's important, not the overall layer of all the number of dissectors. So it's a little bit easier for dissecting some of those when you don't know the layer number.
I think we have time for a couple more. Oh, you have more to add?
Yeah, one addition to creating a development environment, if you're a little bit familiar with Vagrant and VirtualBox, there's a Vagrant config file in the repository as well, and it just means Vagrant up and then Ubuntu, and it will fire up a whole the development engine. So that if you're familiar with Vagrant and VirtualBox, that's the easiest way, I guess. But it's a virtual. Yeah.
One more, in the tools directory, there are setup scripts for all kind of distribution, like macOS with Brew or Linux or whatever, to install the dependencies.
Yeah, we try to make things easier that way too. Hansa?
The IP.adder current behavior is actually quite useful too, so that will be maintained.
Yes.
Yes.
So
the question was, the IP.header behavior is useful. Will it be still maintained? Yes, it will. That's one of the things about our program. We have, what is it now, 1,800 dissectors, something like that?
That's the next slide.
Okay.
But it's up to 2,800 now.
We are very, very bad at throwing stuff away.
Yeah. Any other questions? Online? One more over here. Go ahead.
Maybe I should do this with developers.
No.
The fields that get overloaded, so repeated use in a single frame, will we be able to slice those similarly?
No. I'm laughing because, so the question was, fields that get overloaded by similar dissectors, are we able to slice and see what previous information has been written to them? No. That is a question that comes up quite often, and I totally understand the sentiment behind it. The problem is the information just isn't there to be displayed in the UI or be parsed by the UI.
Yeah. Angelo, did we have another online? Okay, all right.
I just want to add one thing, and we kindly demonstrated that on stage right now. One of the great things about SharkFest is we are managing to surprising each other with new features in Wireshark all the time. So none of us has a single clue what all the features in the programs are. And most of the time when we get together, somebody comes up with, have you seen that we can do that? And everybody else, every developer in the room goes, no, one. Sometimes this feature has been around for ages, sometimes this feature has been added recently. So when we get surprised by the program, don't be discouraged if you get surprised by the program as well, because that's the great thing about Wireshark. After every corner there's something new to learn, and it's just building to the experience that is packet management and packet capturing, and it's just great fun to have.
Online question?
One more question.
Sure.
Which version do you recommend to use to have stability and latest features?
What if you?
Well, so the online question was, which version do you recommend to have stabilities in the latest features?
If you go to the main web page, you know, we have different different releases listed. We have the stable release and then the old stable. I suppose if you prioritize stability, you would want to go with the old stable release because that's been around a long time. We only backport bug fixes. We don't add any new features. We try not to. But yeah, that's going to be the most stable release is what's called the old stable release. The current stable release, you know, if it's like 4.0.0, we'll probably have some bugs. You might want to hold off on, you know, and maybe wait for 4.0.1 or 0.2. It's like any other software release. You know, that first fresh release, people are just going to find issues with it, and we'll try to, you know, turn that around and get it fixed as quickly as possible. Having said that, at the same time, I always run the latest bleeding edge Wireshark that I compiled that very day just to do my daily work, and it very rarely breaks. And it occasionally does, but at the same time, we do. You know, when we check in code, we run tests, you know, in our continuous integration system, and we make sure all that basic functionality works, and that it runs, and it's, you know, that it's at least stable at that level. Yeah.
I was just going to say exactly the same thing.
Okay, sorry.
I normally run the development version, and it very seldom breaks. And if it does, it gets fixed fairly quickly, but it depends what your purpose is.
Yeah.
If you want the latest and greatest and are working with new protocol, I recommend you to use the development version, but maybe keep an eye on the bug tracker and see if there's something seriously wrong with it, but most of the time it's not.
Okay.
I want to add just one sentence to that. If you're going through old documentation, sometimes there are notices about Wireshark being unstable and stuff like that. That had been the case in the way past, but we can't seem to get this rumor killed. We do a bunch of testing, we do extensive testing, and I know more people using the bleeding edge version in productive environments than I know of people just downloading the version.
Okay. All right, we have a minute left, and I have a couple more slides. So, all right. But one quick note while they're getting settled in. This is one of the benefits of SharkFest, the fact that we only get to meet face to face during these events, and so the fact that we're able to meet face to face and work together for a couple of days really does advance the state of the source code and the state of the project. And I mean, I know the main thrust of the conference is to present sessions so you guys learn, but at the same time, this has a benefit to the project at a code level and at a development level as well. But having said that, let's get on to the state of the project. The big announcement we had at the beginning of the year, but it actually took effect late last year, is that we have a new primary sponsor. We have a company called Sysdig that sponsors the project's infrastructure, and they sponsor my mortgage. If you're not familiar with Sysdig, I'd say we because I'm part of the company, but we focus on cloud security, and that might sound kind of odd because Wireshark focuses on packets. The thing to take away here is that Sysdig was founded by Loris Dejuani, who will be co-presenting the keynote tomorrow, and Loris was one of the original authors of WinPCAP, and WinPCAP was the packet capture library we used early on, and that's how we were able to make Ethereal and then Wireshark useful to Windows users, and that's how we got a big user base. Loris also co-founded Case Technologies, which was the project and sponsor from 2006 to 2010. Case is where we started SharkFest, and so me going to Sysdig was a lot like going, kind of coming home. And Loris has been a big supporter of the project, through the main obvious ways, but other ways as well. And we are kind of short on time, but I will say that one of the things that impressed me was that the company is founded on open source. There's an open source project called Sysdig and another one called Falco, and I have all these coworkers that just work on open source all day long, and it's an amazing thing. Two more slides, and I'm done. If you guys want to get out of here, sorry. Quick rundown of vital statistics. We get regularly more than 1 million downloads. Actually, we get quite a bit, more than 1 million downloads per month on the servers that we manage. This is just mainly, as it shows down here, the Windows and Mac OS installers. This doesn't cover, say, Linux distributions. I have no idea how many people use Wireshark on Linux or download it each month, but what can you do? As Roland was talking about the number of protocols we support, we're up to 2,800 now with the upcoming 4.0 release, and 228,000 dissector fields. So when I was talking about display filters, there are 228,000 distinct fields. I expect you to have them all memorized by the end of this conference. One of the things I love about the project is that we're up to 2,000 people that have contributed code to the code base since we started up. And I love the fact that we're still able to attract contributors and kind of be vital and healthy that way. And finally, we're kind of weird on the lines of code. We have somewhere between 3.2 and 5 million lines of code, and that depends on how you count automatically generated code, because we have a crap ton of that. And so if you only count handwritten code, we're down around 3.2 million lines, but if you count all the code in the code base, including automatically generated code, we're up around 5 million lines of code, and that's a lot. Finally, I wanted to say thank you. And I always make it a point to do this at the end of every talk. I can't stress enough how much Wireshark is a great and wonderful thing, and it's not because of me, it's because of you all. It's because of all the users and developers and educators that contribute to the project and help improvement continuously over time. And since we have two special guests here, my parents, I would also like to stress that Wireshark wouldn't be here without them, and not just because they had a baby boy many years ago. But no, it's because when I was growing up, they stressed the importance of both higher education and practical education, and they taught me to be unafraid to apply either or both when that needed to happen. And so when I was working 20 miles that way in Overland Park at an ISP here in town, and we needed a protocol analyzer, it was a very short jump to take the knowledge that I'd learned and start kind of working on a protocol analyzer. They also taught me the importance of community. Ever since I can remember, they have worked in support of sea service veterans, Navy and Marines and Coast Guard, and they have also worked in support of the children's homes here in town. And that stress on community, I think, was one of the reasons that I ended up making Wireshark open source and opening that up to the community and doing that. And so, again, thank you all, and thank you, Mom and Dad, for Wireshark.